All right, welcome everyone, and thank you for joining us today for I guess it's our second last of the 2024-2025 Transforming Construction webinar series. As usual, I'll be the moderator today. My name is Brandon Searle, and I'm the Director of Innovation and Operations at the UMB Offsite Construction Research Center. So just a quick webinar overview. I'll do a brief welcome, then I'll a brief introduction of the Offsite Construction Research Center, as well as Building Transformations, who is our collaborator and partner in delivering this webinar series. I'll then do an introduction to our speakers from VBC, Jill Kaler and Sam Bailey. They'll do their presentation, and then we'll have a Q&A and moderated discussion at the end, and followed by a wrap-up. So just a reminder, we're in a Microsoft Teams webinar format. So if you want to submit any questions, please refrain from using the chat. Use the Q&A feature instead. That sends the questions to a question bank, which we're able to monitor and archive as we reply to them during the Q&A session. If you have difficulty hearing, just check your speaker settings and audio settings. If you have any other problems, just type it in the Q&A there, and my colleague Roshni or myself will be on it. As a reminder, all sessions are being recorded and made available on our website, as well as the Building Transformations YouTube page. And we also post a blog kind of summarizing the presentation, which is also made available on the OCRC website. So I encourage you to check that out. Just quickly about UNB. So UNB is located in Fredericton, New Brunswick. It was founded in 1785 and home to Canada's first engineering, computer science, and forestry programs, with the first engineering course being taught in 1854. Since then, UNB has grown significantly with campuses in both St. John and Fredericton, New Brunswick, over 25 leading research centers and research chairs, and has also been very successful in fostering a startup community in the Maritimes, and was named the top university by Startup Canada back when it was last announced in 2013. So just quickly about the Offsite Construction Research Center. We were started in 2018 through a collaboration with our founding partner, OSCO Construction Group. Since then, we've grown to have an advisory board representing all stakeholders within the construction supply chain from across the country. And in 2022, after kind of formalizing our board officially, we went through a strategic plan where we highlighted what our values are as a research center. We're focused on industry relevance. So while there's important research that happens that what I'd classify as discovery research, our focus is more on working with our industry partners to move the needle in their day-to-day activities. So we focus on applied research being industry relevant collaboration, whether with industry, government, or our academic peers at other universities. Excellence, obviously being a university, everything's done to high academic standards. Then integrity, so our actions and interactions are guided by strong moral and ethical principles. Everything we do often has to go through our ethics board as well. So just being an academic institution, it's important to be mindful of that. And then in terms of where we focus, this is happened somewhat organically, and as we continue to grow over the last 6 or 7 years, where we continue to grow in these kind of key areas. So one is process and productivity improvement. So obviously, Volumetric Building Companies, you'll see they are a manufacturer amongst, in addition to many other things. And what we do is often work with manufacturers looking at productivity improvements or doing time studies, simulations, and things to improve quality, safety, factory layout, and design for manufacturing and assembly. We work often on digital technology implementation, which is kind of enabling some of the process and productivity improvement. That's using BIM, VDC, augmented, virtual, and mixed reality. Over the last handful of years, we've been focused in the kind of structural testing, looking at panelized and modular connections, MEP connections, construction material testing, and more recently, we've launched our new high performance building research lab, which will be able to do air and water leakage testing for building enclosures and building envelopes. And then finally, which is more my area of focus, is in benchmarking and innovation in construction. So understanding kind of the maturity of the sector, the current trends, the current reasons for their drivers or barriers in the sectors, and how do we resolve those, whether that be through policy, guides, standards, procurement, contracts, etc. Beyond that, I serve as on the board of Building Transformations, which is a not-for-profit member-led association operating in Canada and the US, focused on fostering industry innovation by providing programs which help members push the industry forward. Some of those programs involve webinars like this one today, many in-person events, and partnering with the members on in-person events. There's a certification program for digital project delivery, think tanks, awards program, publications, and then career posts. Little bit about the organization. So it is very industry led. Over 60% of the members do come from private practice, or they are private practitioners, while just under 40% are from academia and government. If you're interested in checking out the membership, you can visit the website, buildingtransformations.org. And if you're interested in looking at the Innovation Spotlight, here is a publication we put out annually, which highlights some of the innovative projects happening across the industry. And the 2025 Innovation Spotlight was launched just in mid-March. Sorry. Finally, our event schedule. So this is a bit outdated now, but so far in 2025, Building Transformations had AGM in January, Montreal Spotlight publication launch in March. We were in Austin, Texas for the Future of Design and Construction event, and then we're hosting an event in Toronto, Ontario in October. I believe those dates have been finalized, so you can check out the website for that. There's a few other events being explored, including Arizona in 2026, as well as potentially Halifax, Nova Scotia in 2026. Just a quick thank you to the BT mission partners, particularly PCL, who's been the strategic partner for a few years and running now. And then thank you to our kind of founding partners at the Offsite Construction Research Center, both the Government of Canada as well as OSCO Construction Group. And my last thank you is to our marketing partners who help us promote all the events and webinars that we do here at the OCRC. So now I'm going to welcome Jill Kaler and Sam Bailey from Volumetric Building Companies. Jill is a former VP of Design and now a consultant with VBC, and Sam Bailey is the VP of Pre-Construction. They'll be presenting on Innovating Student Housing, the Case for Modular Construction. So Jill and Sam, if you'd like to turn on your video and microphone and share your screen, I'll give you a thumbs up when everything works on my end.
I think so. Yeah. Share your window.
Looks good from my side.
Still okay, Brandon?
Yep.
Great.
Okay, wonderful. Well, first and foremost, let me make sure everybody can see us and hear us okay. So good afternoon, everybody. Thank you for attending today. I'm going to touch a little bit on the history of who we are and who VBC is. So I'll start with some of the more significant milestones over our life cycle here in the last few years. 2009 to 2017, the young Australian there on the left-hand side, Vaughan Buckley, our CEO and founder, we used to develop and build townhouse-style projects all over Philadelphia. Ultimately, he created a JV with his preferred modular supplier to satisfy his growth and his growing business to provide larger commercial-type projects in a more vertically integrated way. In 2019, VBC took ownership of our first manufacturing facility that was located on the East Coast in Hamlet, North Carolina. And then since then, we expanded into the vertical integration to provide in-house design and engineering. It's a really big step for us to provide those services across all of our projects. This is really the beginning of the last several years of explosive growth. So if you speak to anybody here at VBC, we'll refer to that fondly as the fun years here. And in 2021 to 2023, VBC purchased a West Coast facility. We purchased 2 EU facilities. We decided to relocate our Hamlet facility up to Berwick, Pennsylvania, or Northeast PA. That is now the sort of central East Coast operations for us. And then we brought on board a dedicated design and engineering center in Ireland as well. So 2021 to 2023, as you can imagine, were very busy years and very exciting times here at VBC. Most notably on this, 2024, we had the pleasure of welcoming Kevin, our Chief Paw Officer, represented there in hard hat and safety vest at the Tracy facility on the far left-hand side, or excuse me, yeah, far right-hand side, to the VBC family. And then in 2025, as we continue through our adventure this year, the team continues to serve all of our market segments globally through our 5 manufacturing facilities located across the globe and providing volumetric modular solutions both in wood and steel. There we go. So why modular? What are we here to learn about today? Time is money. In an industry where costs seem to only be going up, every month that we can save on the front end is a month of general conditions. Every month on the back end is a month of operating revenue. Certainty is super important. Providing certainty starts with increasing predictability. For VBC, that's all about controlling supply chain and products that go into our projects. As a result, the volumetric modular portion of a project is often the largest percentage of a project, thus increasing the certainty over the entire project. Better buildings. The manufacturing process itself really provides a level of quality control over simple things and simple tasks like draft stopping, sealing of exterior penetrations, things that just aren't possible with site built construction. And as a result, every project we provide inherently performs better. Sustainability comes standard with our product. You're not paying more for something that really should be common practice. For VBC, this is not a marketing message. I know that's common out there in the world today. It's embedded in the way that we do our business. Improved efficiencies. Automation provides a more consistent tack time with greater accuracy than any site-built construction can. It's a great advantage that we offer. And then lastly, flexible designs. As a client, leverage our catalog of standard units, finishes, and products to fully unlock the advantages volumetric modular can provide. So what we're here to talk about, the word modular can often mean a lot of different things across the globe and to a lot of different people. Specifically for us, volumetric modular is where the entire 3-dimensional units are manufactured offsite, transported to the site for assembly. These units include structural elements, interior finishes, full MEP services. This is really the heart of the value proposition volumetric modular provides. It's really that balance between providing the highest possible level of finish inside the units that minimizes the cost to connect and complete once on site. So where do we do this? Where do we make sense? So from our Berwick facility here, Northeast PA, using our VMX product, we do type 3 and type 5 wood frame projects. We serve a 500-mile radius and a 300-mile zone. The 300-mile zone is ideal for transportation efficiency. It's closer, it costs less to transport, while areas in the 3 to 5 will often occur a slightly higher premium for transportation. It's further away, it costs a little bit more to ship them there. It makes sense. Oftentimes, these are also going into lower cost of labor areas as well. And that combination can make projects in this radius sometimes financially challenging. That said, there's also projects on a case-by-case basis that break down this conventional wisdom. Some of the reasons why are the lack of available labor, think limited construction seasons, and maybe that you have the need to just truck in all your materials anyway. Modular can also make sense under any one of those circumstances. For later reference, our case study 1 that Jill will talk about later is a project that's within the 300-mile radius, and you'll see the values that creates. And then in case study 2, that one's outside of that. That's within the 500-mile radius, and we'll talk about the impact the location specifically has on selecting modular for each of those examples. Oops, sorry, apologies. So why modular? Why VBC? We've really been fortunate. We've done 3.6 billion in real estate assets, 6,000 modules. We've got an incredible team with a lot of experience, and we're really looking to offer that experience back to the industry to help drive the entire construction sector towards making volumetric modular their preferred choice and not just an interesting option. And then a few examples of that relative here, student housing examples from our U.S. portfolio. This project was providing privatized off-campus housing for UC Berkeley. It's named 44th Street. It's in Oakland. It's a West Coast project. It was about 150 beds, 5 modular stories, 143 units. And then our next one here is another West Coast project in Berkeley, California, called 1598. This one was much larger. It was about 245 beds, and again, also provided privatized housing for off-campus students at UC Berkeley. Lastly, as a value-added service to our student housing clients, we offer the ability to also include and install project-specific furniture packages during modular unit manufacturing. This contributes to the project's ability to maintain schedule and deliver on time. It's a value-added service a lot of our clients take advantage of. Hand it over to you, Jill.
Thank you. So VBC has multiple product offerings, including our VMX wood and our VMX steel systems. Today, we will be reviewing 2 case study projects from our Berwick manufacturing facility that are Type 3A. Both of the projects are 5 stories in height. But before we start, let's get a quick overview of some modular vocabulary that may need a quick explainer. A mate wall or a long wall of the module is where 2 modules meet. A short wall is where modules typically face the exterior, also called end walls. We do sometimes call the corridor walls as well short walls. A full module consists of 2 volumes built together with a central corridor. So on the line, that is 1 shared floor assembly. A half module consists of 1 volume with or without a corridor. And an interface is a point of connection between 2 things. An interface bump out, or we also call a corridor bump out, is a 2x10 bump out where the vertical connections are made, often at the corridor. A tower is 1 vertical stack of modules within a multi-story building. VMX is our brand offered by Volumetric Building Companies that encompasses a range of modular systems and components designed to streamline construction processes, enhance sustainability, and deliver high-quality results. VMX may be a selection. It may also be a system. DFMA is an acronym that stands for Design for Manufacturing and Assembly, which means products are designed to work with manufacturing and assembly methods in place. EOR is Architect of Record, Engineer of Record. They are the responsible parties for the scope of work completed on site. MAOR and MEOR is Modular Architect of Record, Modular Engineer of Record, and they are the responsible parties for the scope of work completed in the manufacturing facility. The 2 most common ways that VBC is engaged on projects is 1, a client wants to switch to modular from site built for various reasons and already has approved drawings. The VBC team then works with the AOR to convert those drawings to modular. Or 2, a client knows they want modular construction from the onset of the project. Often they have experience with modular and want to continue on that path. In this case, the VBC team designs alongside the AOR through a series of meetings and workshops. In our design process, there is a defined set of parameters we refer to as the system's non-negotiables. These are determined by either transportation, set, or manufacturing requirements. For our VMX wood coming out of Berwick, Pennsylvania, our modules are limited to 68 feet in length and fall between 11 feet and 15'9" stud to stud in width. Our height limitation is that the trailer in the module cannot exceed the DOT maximum shipping height. In many states, this is 4'6". However, the New England states it is lowered by 1 foot to 13'6". As a result, depending on the transportation route, VBC offers 2 standard unit ceiling heights of 8'6" and 9 feet. Our mate wall assembly is 11 1/8 inch for 4 stories or less, and 11 5/8 inch for 5 and 6 stories. Our VMX wood system is line loaded with predominant shear forces on mate walls. Secondary shear is often provided by perforated shear located at the corridors. The structure utilizes a semi-balloon frame or inset ceiling for typical floors, while the roof structure is platform framed. Our maximum opening in the mate wall is 10 feet, and windows should be located a minimum of 2 feet from grid lines to allow adequate room for stud packs. This is especially important in high seismic zones. Moving from the non-negotiables to the recommendations, we've developed a comprehensive list of suggestions, most of which are focused on the zone of the unit closest to the corridor. This area is intentionally designed to be dense with plumbing and mechanical systems, enabling the remaining space to be flexible and adapt to specific project needs. These recommendations offer the best balance of value, quality, and schedule for our clients, supporting the goal of DFMA while streamlining on-site installation. We see this as a distinction between product and project. Product is where standardization provides a high value to the manufacturer, and project is where variation provides a high value to the customer. We are constantly trying to find an appropriate balance between the two. While there are non-negotiables and recommendations for modular projects, there are several positive trade-offs. First, our modular units offer great acoustics. Our mate wall assembly, the demising wall between two units, is an STC 61, as tested by an independent third party in field. The floor ceiling assembly between two stacked units is an STC 58. Second, our VMX selections are mid-luxury finishes at affordable prices. As a modular manufacturer, we work with preferred partners to arrive at the best balance between quality and pricing for our customers. Third, we have designed our VMX wood system for simple on-site installation. We bring all of our vertical connections through the fire-rated wall to the corridor in order that the trades can complete their work outside of the finished unit. Fourth, at times, there is minor work that needs to be completed in unit, and a scope of work diagram will be produced early in the process in order that the on-site GC may appropriately bid the work. The items required to complete the work will be shipped loose with the module. Okay, let's jump into it. Case study number one. Case study number one is an undergraduate student housing project consisting of 1,709 beds located in 3 buildings of 5 modular stories. Portions of the buildings are slab on grade, while others have a level of site-built construction underneath the modular podium slab. The GC was looking towards modular construction to solve labor shortages and increase quality. We began our engagement with the GC team when the AOR documentation was in design development. Here is an image of residential building 1. The areas highlighted in red represent the site scope. For the facade, windows and the weather barrier are installed in factory, while the facade materials are installed on site. The building aesthetic will largely remain the same. The storefront glazing is able to be site installed. Otherwise, if the client wishes to have that installed in factory, it would need to be converted to a punch window opening. In plan, we moved the resident advisor units to level 1 due to the offset corridor. You can see that here in the diagram. As level 1 has a greater height, they utilize drop deck trailers to stay under the maximum DOT transportation requirements. We have more space to offset the vertical connections. The nodes of the building, the corners where the service and amenity spaces are located, have been reorganized to fit into modules. The unit block highlighted by the red line, which repeats across all buildings, was optimized to reduce the number of modules required while keeping the spaces and bed count the same. For case study number 1, we can fit 4 single rooms in a 15'9" stud to stud width or 15'11" grid line to grid line width module, which is our maximum width. This will be the best cost as it reduces the module count, number of transportation loads, and crane picks. If clients elect, the furniture within the module can be fully installed in factory and shipped with the module. By grouping the 4 single rooms into one module, this changes the layout of the unit block. We move the 4 single rooms to the center, which is a 15'11" wide module, to correspond with the resident advisor unit below, which keeps the tower width aligned. The 5th single room is opposite the amenity space and can swing between a single or double depending on the enrollment needs. We adjusted the walls based on the VBC assemblies, keeping the interior dimension of the rooms. The original footprint is overlaid with a red line on the unit and modular plan, illustrating the minor shifts from the original layout. Once we incorporate these modifications over the floor plan, we compare the original versus modified square feet. For level 2 of residential building 1, it was 30,120 square feet, and the modified version is 30,891 square feet, a difference of 771 square feet or a 2% increase in area per floor. For the mechanical system, we maintained the original design. Everything north of the green dash line will be factory installed and south of the green dash line will be site scope. With those modifications, we then run the efficiency numbers to understand the project complexity and factory throughput. Is this project DFMA friendly? In this case, wow. We have 789 modules divided by 82 unique modules, achieving a modular efficiency of 9.62. There are 975 units divided by 9 unique units, giving us a unit efficiency of 108.3. So then we take 2/3 of the module efficiency and 1/3 of the unit efficiency, and we receive a product optimization score of 42.52. This project is a great project for manufacturing.
Awesome. Thank you, Joe. So let's talk schedule. Faster time to market. So in modular construction, site development foundation work occur simultaneously with the manufacturing of the volumetric modular units in the factory. This parallel processing can make modular construction faster than traditional site-built methods. In this case study, our schedule advantage was improved by the ability to turn over one building while the other buildings were still under construction. Generally speaking, the larger the project or a project with one building, the larger the project or a project with with multiple buildings, and with multiple buildings, the greater the schedule advantage. By developing a logical flow to the project that allows for overlapping of construction items like podium work, modular unit installation, and overall completion, the greater the potential for the schedule savings. For example, while building 1 is being installed, the volumetric units are being installed, building 2 could be constructing the podium. Building 3 could then be breaking ground. Modular unit manufacturing runs uninterrupted, and the units begin to be delivered and installed to supply this flow. This also minimizes the amount of time the volumetric units need to be stored. Schedule is really where we can realize the savings that volumetric modular construction can offer, especially on a student housing project that often have a start date that tends to slip, but with an end date that can't move. So this is a good example of how a project's location, like I mentioned earlier, and the site-specific requirements can impact the value modular can provide. This example was in a low-cost labor market with a high amount of site construction and site development work that even going modular could not offset and provide a savings to the overall project. Being cost neutral doesn't mean modular isn't a best choice for the project. It simply demonstrates that there isn't always a hard cost savings to be had. That said, with a semester or a full calendar year of operational revenue, what is that worth to the university? The revenue on a per bed basis varies from client to client, of course, but that revenue needs to be part of the overall cost savings analysis when evaluating modular over site built. In this example, the volumetric modular units, largely just bedrooms. This example opted for a more conventional common bathroom style design, meaning we didn't have kitchens and bathrooms in all the living units. They had a common area for that. And as a result, the cost savings that we did have on the manufacturing side that was available was really less because the spaces that we were providing were less labor intensive and they were distributed, a little bit more throughout the entire building. And Jill, I'll flip it back to you.
Case study number 2. All right, case study number 2 is located within 300 miles of Berwick with 820 beds spread across 2 buildings. The reason the GC pursued modular was to enhance both the budget and schedule. They are a repeating client with modular experience, and the GC elected to pursue modular from the onset of the project. We started by reviewing the conceptual unit plans, applying our non-negotiables. Again, here we looked at grouping 2 single beds into a 15'9" stud-to-stud module width to reduce the overall module count. At the same time, we needed to increase the living space to meet our minimum module width. This increase allowed for the vertical or for the linear kitchen to be located within the module width. So we do not have the crossover of the kitchen over 2 modules. After the module reorganization, we reviewed the net square feet. The original was 845 square feet, and the modified plan is 821 square feet. Outside of the unit net square feet, we do add some additional space for our corridor bump out where the vertical connections are made. Here are some sample images of the unit that show the space with furniture, all of which can be provided in factory and shipped with the module. As we are building everything in a 3D model in Revit, we can very quickly visualize what the spaces are on both the interior and exterior, providing a great value to our clients in their decision-making process. In early discussions with the GC, we decided that the elevator core would be site-built and the modules would be set outward from the core. As the project is from our Berwick manufacturing facility where we produce full modules, alignment across the corridor is required. The typical modular modifications were applied with the minimum and maximum width, plus the mate wall assembly thickness. Here you can see the new layout, which incorporates all of the modifications. There is a red line again that shows where the original building footprint is as compared to the new building massing. And we are at, the original was 28,703 square feet, and the modular is 30,197 square feet. That is a 5% increase in area. And this was our first pass on the project. So then we immediately went and looked at what does this look like in plan, or from plan to 3D. And our first reaction as a collective team, looking at the renderings, was that the building was too flat and needed some more articulation. So we went back together with the AOR and we looked at how we can shift the massing and add module indentation to create visual interest on the exterior. Modules can move relatively easy in and out in length as the space is not system heavy and has less interfaces. And so the result of that coordination is shown here. Minor shifts that can help the overall experience of the building with its surrounding environment and passersby immensely. And as we continue through this iterative design process, we advise the team on where modifications will impact or will not impact the modular approach. For this case study, we have 411 modules divided by 62 unique modules for a modular efficiency of 6.42. There are 250 units divided by 5 unique units for a unit efficiency of 43. 2/3 of the modular efficiency plus 1/3 of the unit efficiency creates a product optimization score of 18.61. Great score for this project.
Awesome. Yeah, that's a great example. So again, let's talk schedule again and faster time to market. So comparing this study to the first one, here again, we saved an entire year on the schedule, providing to the client the ability to realize revenue a full year sooner. I can't emphasize how important that is enough, especially on these larger jobs. But really the same strategy as before. We overlap site development with modular manufacturing. We start delivering units to install in building 1 while building 2 site work is underway. It's just sort of the logical progression of all of these larger jobs where you really realize the maximum advantage. So let's add that up. What's that worth? This is what it's all about. This is what you came here to see, right? Where is modular more cost effective? It's right here. It's in all the things Jill just went through. The significant hard cost savings plus the ability to generate an entire year's worth of revenue made a decision to use modular an easy one. This 20% does not include the revenue bonus. That's to the client's benefit. That's not for us to quantify in this example. A side note here. So even if we are adding additional building square footage, like Jill mentioned earlier, because of the requirements of volumetric modular, we're still less cost overall and per square foot, but giving the client more for their money, essentially giving you more building for less cost. Where we're adding that lower square footage, we're not adding kitchens, we're not adding bathrooms, we're adding square footage in some of the more cost-effective areas. So therefore, there's no negative cost impact. And that's really what efficiency is all about. So Anyone interested in learning a bit more about modular by visiting our manufacturing facility in Berwick, PA, which I would highly recommend, please feel free, scan the QR code shown on the screen here. I'll pause here for a few seconds while everyone has a chance to do that. On May 19th and May 21st, we're offering Berwick factory tours that that coincide with the attendees traveling to and from the SCUP Mid-Atlantic Conference. So looking forward to anyone interested in doing that, and hopefully we'll see you there. Again, I'll pause here for a few seconds. Then our final slide of the day, for direct contact information, please reach out to our business development representatives here shown on the screen based on your region. We look forward to hearing from you. Thank you again for your time and interest in this presentation. It's been our pleasure on behalf of Jill and myself. We're always passionate and always happy to talk about this. So welcome anyone's feedback. And Brandon, I'll turn it back over to you.
Yeah, thank you, Jill and Sam. That was great. There's a few questions coming in there, and I guess so. We have about 25 minutes or so, 20 minutes for questions. I might get started quickly with maybe a bit of an easy one that I wrote down, and then we can get into some from the audience, and hopefully while we're talking, the audience that will spur some more questions from them. But during the case studies, I think particularly in the second one, you mentioned that the GC had experience with installing modular projects. Can you maybe just speak at a high level to the importance of having that GC that has had experience and understands, how the trades work differently, how the site work happens, how the work breakdown structure changes between site and factory, and maybe also from a building inspection point of view. So here,
Sure.
I'm not sure in the US, but as much in the US, I should say, but here a lot of factories are CSA 8277 certified. I'm sure it's similar there. And then some authorities having jurisdiction will accept that, others won't, and if they're not as familiar with the modular process, they'll ask their inspectors. Will have to go to the factory, or unfortunately, the inspectors might want to tear walls apart on site. So can you just speak to the importance of the GC having familiarity and how you work with the building officials and things like that?
I'll take the first part. I'm going to take second. So yeah, it's a great question, actually. I mean, to that point, I can't emphasize this enough as well. This is a very much a journey, right? This is a different process than conventional sort of path and site build that everyone sort of knows and is comfortable with. And there's a ton of value to it, but there's also a learning curve, frankly, right? So a lot of the things that we talked about today and laid out are very much in that vein. This is how you maximize and take advantage of all the things that we're trying to offer. We're essentially trying to make it easy for you, right? But it takes a couple of projects, to be totally honest. Your first one will not go the way that you had hoped it went. There'll be scope gaps. There'll be lessons learned. That's natural. It happens on site built projects every day. It's going to happen on modular projects as well. So we really try to advocate that message from the very beginning that, understand we're on a journey. We're a partner with you. We're trying to walk this path with you. We'll support you. Let's work together. That's where that scope of work that we had shown up earlier is super important, right? Demonstrating what we're doing and not doing early in the process to get everyone comfortable and get everyone on the same page. There's a lot of things that we do like that through the evolution of the process and documentation and scopes of work and specs and drawings and submittals and really everything that we can to educate and train and teach and be transparent that will lead to a successful modular project. But it takes probably 2 or 3 to get to that point. If you take advantage of all the things we offered, I talked about, efficiency and design efficiency and all those things. If we have a client that embraces that from the very beginning, it makes that learning curve much less. And Jill and I personally advocate that a lot on the front end for that lesson. We're trying to help. And oftentimes we have to tell our clients, please listen. We're trying to help you. Please listen. But to your point, Brandon, yeah, it takes 2 or 3 jobs to get to that point. This example, they had a couple of them under their belt already. It wasn't specifically just installation. Frankly, it was the entire modular process. They seem to understand that a bit. They've gone through it a lot. I suspect we'll work with this same team on multiple projects. I think we're all looking forward to that on both sides of the table, and it'll be a great relationship, I'm sure.
And from a review process and permitting process, each factory is contracted with a third-party agency. The majority of states, not all, but the majority of states in the U.S. Do have a modular program, which means that we provide our documentation to that third-party agency. They review on behalf of the state. They approve our documentation, send it to the state for record, and then we're able to build off of that in factory. They also have the inspectors come out to our factory and inspect each of the unique modules that go down the line, with the expectation that after the unique module is signed off, that every module that follows that unique module is manufactured in the exact same way as the previous one. As a result of this, once we receive our modular documentation package, we provide that to the AOR. They attach it to their building permit submission to the local authority having jurisdiction. The local authority having jurisdiction sees that that's already state stamped, and then they do not conduct a review on the modular portion of that project. Another thing I always like to point out is that when you are applying for your building permit with local jurisdictions, you apply on the square footage of the site built portion only, and you pay your permitting fees to the local authorities for your site built square footage only as well. So this can also provide some cost savings to the overall project, especially for large projects where those permit fees can be over $1 million.
That's a great point. Hidden savings, hidden Easter egg there.
Yeah. Yeah. No, I didn't think about that point. That is interesting. We're starting to get. I think we sparked some thoughts because we're starting to get some questions here. So I'm going to go a bit of rapid fire through them. And the first one, I think that it's specific for you, Jill. This was how do you deal with MEP connections between units while maintaining the fire rating in the plant?
Yeah. So when it's, let's say, within the same unit and we're crossing over a mate wall, so in unit connections, we do have a detail of how we stop the MEP connection on each side and how that is very easily connected on site. So in those locations, there is some additional some work that needs to be completed on site, especially around, leave outs and drywall. All of that material will be shipped loose with the module, with instructions provided on how to do that. We also do have modular supervision in a construction team at VBC, so they can come out, provide that supervision on site to make sure things are done correctly. When we come out to the corridor, we bring the connection through the fire rated wall. We do the horizontal fire caulking in factory, and then typically with MEP that will just be connected down the length of the corridor. So we are not providing anything in the corridor that runs horizontally across the units. Often because that dimension of, let's say, if our module is 12 feet in width, having 12-foot increments, can have more areas where there can be air leakage. And so we want that scope of work done on site. And then any sort of vertical shaft connection, that would be fire caulked on site as well.
Great, thank you. I'm not sure, Gashiar, if that answers your question. If not, feel free to send another note there. Going to Brian now. So Brian's talking about weight restrictions as it relates to shipping. So there's increasing weight restrictions on shipping, primarily focused on truck size and weight on the provincial and interstate highway systems. Do you see this as a problem that could limit how full modular is shipped in the future? Or is that something? Yeah. I know Helena has talked. I've talked to Helena about this before too. Yeah, your colleague.
This call's not long enough for us to get into logistics. I'll go down a rabbit hole with that one. But no, it's a good question as well. I mean, look, part of this front end analysis, we didn't even touch on sort of a little bit of our front process, but part of that is assessing sort of the feasibility of a job, right? We don't move forward with any real significant documentation until we've assessed that site. Can I get them there? Length, width, height, weight also. And then we do a front end sort of initial logistics plan and a pick plan, again, to kind of finalize that feasibility. That feeds directly into the design process a bit up front. So that we're all working from the same, in the same direction. And then we know the job can be done. We have a strong database of what we know these modules weigh. We build a very consistent product. We build a lot of it in the very same general areas. We have an extensive network of team here that helps support that in the field, that gives us feedback on the front end. So we have a lot of data for this. We've not really had much of an issue. You can build modules that are too heavy or that get heavy, yes. But because you know the weight and you anticipate it in the very beginning, you avoid that situation from happening in the backside altogether.
Yeah, no, that's perfect. Yeah, and I guess just building on the transportation aspects, one of my colleagues here, I know I have a general idea of where this question might be coming from, but she's asking what techniques are put in place to minimize damage occurring during transportation, or is that a problem that you've encountered and kind of had lessons learned from the many projects that VBC has done?
Yeah, that's a good question too. So we take a lot of precaution. I mean, this is really at the core of that value proposition, right? It doesn't make any sense to deliver something only have to redo it in the field. That works against exactly what we're all about. So we do a lot of prep in the factory prior to shipping. Things like protecting corners with non-abrasive, non-penetrating, non-sharp edge materials. Any duct that sticks out, and as easy example, we literally wrap everything on our modules from the floor all the way up. We do an extensive amount of detailing and work on the tops of the modules to kind of keep them dry and keep them, weatherproof at all aspects of the operation. We go above and beyond really to ensure that there's no issues. The biggest thing that you can do is just keep everything dry and keep everything protected so that you don't have that sort of damage occur in the first place. And
that makes sense for sure. I know one issue that a company we had worked with, they were finding some issues during transportation with just the drywall cracking and things.
Sure.
Mostly aesthetic, sure. And that. So we were looking at like the forces on the module during transportation, and I think that ties to like how you brace things optimally and different things like that.
It's all in how you build, right? Your assemblies as well. We do a lot of bracing. A lot of shear wall, a lot of perpendicular framing, both in drywall and shear wall sheeting to minimize that. So it's really about making sure you understand how your product reacts and is transported and picked down the road. It's part of our process. We have to be experts, not only in design, not only in manufacturing, but in delivery and installation as well, because ultimately at the end of the day, that's our product, right? It's from front to back. It's a full service product. So we take all those steps in the factory to minimize that.
And I will add to that, with 6,000 modules built, we've had a lot of experience, and our product has not remained the same over the years. It has evolved, and a lot of that evolving has been because of the lessons learned. So for instance, we now have inset ceilings, and that helps prevent the cracking of the modules during transportation.
Yep.
So a lot of how our product develops is a result of what we hear from our construction teams, what we hear from the set crews, to feed back into that continuous learning loop.
Nice. No, that's great. And sometimes I think in construction we don't do enough of that because we're always just chasing the next project or reacting to the next thing, and just the reality of the industry. So a colleague here asked, in both case studies, the time savings that were presented, were they calculated and shared with the client prior to construction, or those based on actual post-delivery and completion of the timelines? And if they're communicated beforehand, what was kind of the data that was used? Was it based on historical projects that you've done and part of the kind of pre-construction, and did you actually maybe compare assumed schedule versus post or actual schedule?
Yeah, that's a good one too. So front end, it's all about planning, right? Our entire process is a planning process, effectively. Schedules, it's really about schedule of what we do. So we certainly provide all of that information really from the very beginning, frankly, of what we're planning in our process. It's an educational process. It's a visual process. So schedule is really important for our teams internally and externally, and to the clients to understand how to best take advantage of what we do and what we need to give them that value proposition. And then we go through that then is managed through, right? We have a full service construction team, project management team. That evolution of that schedule runs all the way through the entire construction process, and then is reported back on kind of a lessons learned. So in this example, the second example is an in-process project. We're pretty far down the path. We expect that all of that value to remain, if not get greater, frankly, because we've got a repeat client with an amazing design and an overall, it's a great project and opportunity for us. We'll see if it holds, but we expect it to.
And to mention, the site built comparison for schedule and cost came from the client themselves.
Yeah.
So we did work with both the clients for the case studies to receive that information from them.
Yep. Very collaborative process. Yeah. Good point.
Yeah. I'm going to go away from this for a sec. So just, you talked about collaboration a lot. And I think a lot of times when we look at it and when we're talking to owners, infrastructure owners, whether it's public housing, academic institutions providing student housing, whatever it might be, they're looking at they're looking at having to try new contractual methods or procurement processes that are more collaborative. I know AIA released maybe just last week some of their new guides. Can you maybe just mention the type of contract or procurement structure that was used that allowed for you to work with that GC or designers and that owner early on? Because again, you hear it all the time. Any form of offsite, whether it's volumetric modular or mass timber or precast, whatever it might be, the more the offsite company is integrated into the initial design, the more successful the project. But sometimes the procurement process doesn't allow for that to get competitive pricing and compare, bids competitively. It doesn't allow for that. So can you just talk to that really quickly? Yeah.
Yeah, I mean, this is the journey that we're on, right? This is honestly back to whatever my first or second slide was. This is why we're here. It's education, it's giving back, it's letting the world understand the process to best take advantage of it. Part of that is contracting. We're a unique entity, right? Manufacturing has its own specific needs. Unfortunately, the rest of the construction industry, the contracting industry in particular, AIA in particular, doesn't have standard templates that apply for what we do. They just don't speak to it. It's a different world. This is what we're hoping to accomplish. Ultimately, we'd love to use AIA contracts. We have no issue with them. They just don't speak to what we need yet. So we're hoping that this evolution and giving the feedback directly influences that to get it to that point. In the interim here, obviously we have our own contracts. We have our own attachments, our own exhibits, our own payment terms and those things. They're different from the rest of the world. But they're what's required to best leverage this process. I can't offer a year savings advantage on a schedule if I don't have a more aggressive payment term as well, right? They all kind of go hand in hand. So we're hopeful. It's a great question. We're hopeful that the industry turns around and sort of creates more templated, standardized documents across the entire construction field that speak to modular. I think we're seeing some of it, frankly, on a smaller scale, but AIA I don't think is there yet from what I've seen.
Yeah, they with the new documents that they released last week, we're currently still in the process of reviewing those with our legal team just to see how our contracts overlap with theirs.
Fun stuff.
Yeah. So we'll probably have more on that in the next month to understand where those how different or how like they are from what we typically use.
Yeah, no, that's interesting. I'd be interested in knowing that because so for the folks on the call that are mostly in Canada, AIA is the American Institute of Architects, and they have contract templates like we have called the CCDC documents here in Canada. And so oftentimes the CCDC 5B is a CM. There's CCDC 14, a design build, and CCDC 30 is an integrated project delivery, but many of which need amendments and modifications for volumetric modular. And there are some colleagues across the country that use that as a template, but as you mentioned, payment terms need to change and vary project to project and sometimes manufacturer to manufacturer and so on. Sorry, I'm going to go to one colleague here. So Ahmed, and he's with the province in the education in space and an engineer as well, so know him fairly well, and he's been very supportive of our center. So he's asking, I'm new to this type of construction, especially at that scale. Very informative and great presentation. In your slides on must, best, and recommended practices, is there an industry guide or code book that can be reviewed with respect to these items in modular construction? I know of some textbooks and things. There's about 10 of them on my shelf in my office, but I'm curious what you guys have used or where you might direct people that are interested in this space.
Yeah, there, as you mentioned, there are, textbooks. I think what we probably really have to do at VBC is write a book for each one of the factories, in each one of our products, because it does vary from factory to factory and product to product. And a lot of that's, based on how manufacturing lines are set up. For instance, our Tracy facility has the manufacturing line runs between the structural grid, and the structural columns are 40 feet apart, meaning that we can't do modules greater than 40 feet down that facility, which that then changes, the way we connect our buildings, where we connect our buildings, the interfaces, how do we manage those? So it does vary quite a bit. And, I think really as Sam mentioned before, with repeat clients, as they work with us, the first time it may be a bit more challenging to understand all of the requirements and why it's a requirement. But as they continue in projects beyond that, they get very familiar with our systems and our products. So for first time, I'd say, reach out to us if you want to know more. We're always here to help. We have a great business development team that can, walk you through the ins and outs of what you're specifically looking at. Go to the factory, visit it, see how we construct, because now all of a sudden those requirements and non-negotiables and then the recommendations make sense.
Yeah, and like I think that's why we do these things, right? That's why we do these webinars, and we've used the word education a lot in this presentation. It is very much that this process and sort of things that we do and why we do what we do and why it's important and how we communicate that is a very much an educational process. Brandon, if I can jump back to a little comment you made on something that I just want to stress is super important and relative to this comment actually as well. You mentioned about the timing and when to get engaged with a specific manufacturer. We didn't really touch on that so much. I think actually Jill did in case study 2, I believe. But just to drive that point home, I can't emphasize that strong enough. Everybody sort of does their version of things slightly different. We're really trying to create a whole ecosystem that clients can come in and take advantage of and work within. There's not a lot of other teams and other manufacturers doing that sort of thing. So whoever you end up going with, it is absolutely critical to embrace and take advantage and select and work hand in hand collaboratively with that manufacturer from the very beginning, as early as you possibly can. You cannot wait and go through conventional wisdom and go through a DD set and put it out to bid, and then all of a sudden decide you want to go modular. Those are some of the hardest projects to turn, and often some of the ones that don't end up that well.
Yeah,
So
yeah, no, absolutely. Yeah, you don't realize many of the benefits that your case studies talk about, and I think with the owners that we've worked with at the research center, looking at best practices for procurement and stuff, a lot of it drives they still need 3 bids on every project. And so how can they, so if they're doing typically a design bid build, well, then you're hiring your designer, then, you put that design out tender, and then you're hiring your GC. But if there's a modified, say, design build where you ask a design team to come together with a general contractor and a manufacturer, and you can still get your 3 bids, and that's where they can still, as a public entity spending public money, they can still go with the most competitive price, but you can engage that manufacturer. That's where the hiccup, from my perspective, it's always been like, well, we can't sole source to a manufacturer, so we can't engage them early enough. Whereas with the design team, sometimes it's a bit different. There's a lot of questions here, so I'm going to try to go a bit quick. We'll document them and maybe share them over email, and if you have time to respond, that's great. If not, I understand. But I'm going to go in order of what came in the earliest and go through it. So first one was, what kind of digital transformation do you have in your Revit templates and automations in the design phase? And is Revit a bad word at VBC? I don't know.
No, we love Revit at VBC. We actually have integrated technology through our entire VBC platform. So it's not just design that goes to our procurement, our factory management. It at times even feeds our automated machines. So we do have we do convert our Revit models through another software that feeds directly to our machines, which can cut our 2-bys. They can do nailing patterns automatically, which saves a lot of waste and increases our sustainability as a company as well. And then it goes all the way to the field. So each module, will get a QR code that can be scanned, tells you what inspection reports are related to that module, when did it receive approval, what are the ship loose items in that module, what needs to be finished, where are the details, so you can pull those up and see what that is. So there's really, the technology for us is really about this technology platform rather than just Revit as an entity on itself. And we really try to utilize that, across the board, from not only a design perspective, but a cost, scheduling, procurement, construction, and manufacturing components as well.
Perfect. Yeah, no, that's great. And I am mindful of time, so I might cut it off there. But for the audience, I'm going to document the questions that have come in, and we'll make sure to share those. There was one question that came in around the presentation. So yes, the recording this has been recorded and it will be shared. We'll double check with the presenters and make sure that everything in the presentation is able to be shared as maybe a PDF. The presentation to the audience is I know sometimes there's some stuff in it that's confidential, and sometimes you don't want it out in the world. But anyways, all that said, I want to thank you both very much for taking the time today. It spurred a lot of conversation. I know a lot of folks on the call were eager for this one. VBC is continuing to grow, and that last 15 or so years, there's been a lot of growth, which is great. We actually had Helena Lidlow speak at our conference locally last August, so that she was fantastic as well. So thank you both for your time. Our next webinar for the folks on the call is going to be May 15th. We're trying to secure someone from Infrastructure Canada for that one. We're just working through some of the processes to do that. And then we're going to have a webinar in June where we're actually going to be presenting a roadmap that we've been doing for industrialized construction for the federal government here in Canada. So I encourage folks to keep an eye out for that. And both Jill and Sam will make sure to share that with you. There might be some lessons learned as well. So thank you both very much. Enjoy the rest of your day and enjoy the long weekend for those who are celebrating. Have a good one.
Thank you, everyone.
Thank you.
Take care. See ya.